Welcome to Spring LIB.
Question number 127 is an ideal gas law question. It is a stoichiometry question, and it is a two-equation, two unknown question. It mentions that 6.53 grams of a mixture of magnesium carbonate and calcium carbonate is treated with excess hydrochloric acid, and then a certain amount of carbon dioxide gas is released. So the two reactions that are occurring are magnesium carbonate reacting with HCl to produce magnesium chloride, water, and carbon dioxide. Then the calcium carbonate also in the mixture will react with HCl to produce calcium chloride, water, and carbon dioxide. This is part A, where you are simply asked to just write the two reactions that are occurring. Then you need to calculate the total moles of carbon dioxide that forms from these two reactions. This is where we now conduct an ideal gas law calculation. We recall that the ideal gas law is PV equals nRT, so rearrangement of this equation will be moles is equal to PV over RT. The pressure is 743 torr. 743 torr needs to be in units of atmospheres in order to use this equation with a common R value of 0.08206. So we'll convert the torr into atmospheres by dividing by 760 torr. Then we have our volume in liters, which was given to us at 1.72. We divide that now by R, which is 0.08206 liter atmospheres per Kelvin mole. And then we have in the denominator the Kelvin temperature. Temperature for the carbon dioxide gas was 28 degrees Celsius, so we add on 273.15 to convert it into Kelvin, so it will cancel these Kelvin units in our constant. And we get a total of 0.06804 moles of carbon dioxide being released. Now the next part of the problem is the most difficult part. This is where we need to do a two-equation, two unknown calculation. The first equation is rather simple. We know that x plus y, where x is the amount of magnesium carbonate and y is the amount of calcium carbonate, that their summed mass equals 6.53 grams, which was given to us in the problem. But what about the next equation? We can't solve this with two unknowns. We would need another equation. The other equation is going to come from the moles of carbon dioxide that was created. The moles of carbon dioxide that was created came from the magnesium carbonate and the calcium carbonate. So if we didn't know the moles of carbon dioxide, but we did know the individual masses of magnesium carbonate and calcium carbonate, we could solve for the moles of carbon dioxide by taking the mass of magnesium carbonate, which we define to be X, which we currently don't know, and we would divide it by the molar mass of magnesium carbonate. This would give us the moles of magnesium carbonate that we have to make carbon dioxide. We would then look at the stoichiometry of the reaction and see that it is 1 to 1, so we could convert the moles of magnesium carbonate into moles of carbon dioxide with a 1 to 1 relationship. But magnesium carbonate is not the only species producing carbon dioxide, so we need to add on the moles of carbon dioxide that would be created by the mass of calcium carbonate, which we have defined to be Y. To get the moles of calcium carbonate, we would take its mass and divide by the molar mass of calcium carbonate. This would then be the moles of calcium carbonate that we have to produce carbon dioxide. We would then look at its stoichiometry and see that it is also 1 to 1. 1 mole of calcium carbonate produces 1 mole of carbon dioxide. So this summed total of carbon dioxide coming from magnesium carbonate and calcium carbonate would equal the total moles of carbon dioxide created. Now we have two equations and two unknowns. So we can rewrite this, getting rid of the units so it looks a little simpler, and substituting in for y, rearrangement of this equation. Y is going to be equal to 6.53, bring over the x, minus x. Then what we will do is divide 84.3139 into x, and we'll get 0.0118x, and then divide this into both the 6.53 and the negative x, and we will get these two numbers here. Then we will combine our like terms, combine these two numbers, and then combine our x terms, and we get this. Then all we need to do is divide both sides by 0.018687, and we'll get x equal to 1.50 grams magnesium carbonate. So y then must be equal to 6.53 minus 1.5 minus x, or 5.03 grams calcium carbonate. So then what we have to do, because it didn't ask for the masses, it asked for the percentages, is we need to take the mass of magnesium carbonate divided by the total mass of the mixture multiplied by 100 in order to get the percent that is magnesium carbonate, 22.9%. We'll do the same thing with calcium carbonate, 5.03 divided by 6.53 times 100 gives us 77.1% calcium carbonate.